Hello everyone, now we are going to discuss the gyroscopic couple. In the last topic, we have considered the concept of angular acceleration and we have seen where that what is gyroscopic acceleration. Again, I'm going to explain you. Alpha is basically d omega by dt I cap, that means in the x direction, plus omega omega p j cap, and this omega p basically is the gyroscopic acceleration. This is gyroscopic acceleration. Okay, so if only direction of omega is changing, magnitude is not changing, that means d omega by dt will be equal to 0, because this is responsible for the magnitude and this is responsible for the direction. Okay, we all know that. So if only direction of omega is changing, magnitude is not changing, then d omega by dt will be equal to 0. Okay, so if only direction of omega is changing, and magnitude is not changing, if only the direction of omega is changing, magnitude is not changing, in that case d omega by dt would be equal to 0, because it is responsible for the magnitude, we know that. Okay, so you can see that alpha would be equal to only omega p, because only direction of omega is changing. So in that case, angular acceleration would become equal to omega p, and the direction is y direction. Are you getting my point? So therefore, to have precision, it means to change the direction of omega, because we know that the change in direction of omega is also known as the precision. Okay, we have termed it as precision. So therefore, to have the precision, it means to change in the direction of omega, in order to provide alpha would be equal to omega p in y direction. So in that case, external torque is required to be applied to the system. So that requirement of external torque is known as basically active gyroscopic couple. So let me write it. Therefore, to have precision means, therefore to have precision, it means to change in the direction. It means to change in direction of omega, in order to provide because we want only change in directions. Okay, we have neglected the change in magnitude, or we have assumed that the magnitude is constant. So in that case, alpha would be equal to omega p. So in order to provide alpha equal to omega p, and direction is oy, so external torque is applied to the system. Are you getting my point? So external torque is required to be applied to the system. Okay, so that requirement of external torque is known as active gyroscopic couple. So that requirement So that requirement of applied external torque is known as active gyroscopic couple. Active gyroscopic couple. Gyroscopic couple. I hope you will understand this whole procedure, this whole concept. Active gyroscopic couple. Okay. So what would be the active gyroscopic couple? It is denoted as C, that is equal to I alpha. Basically, it is a torque. Okay. But this torque is considered external torque which is required to apply to the system in order to provide alpha is equal to omega p. So that's why it is I alpha, and where we know that alpha is considered as I omega p. So it would be I omega p, and the direction is same, forward direction. If you are not able to understand the directions, let me draw the diagram again. This is x direction, and this is y direction, and this is z directions. Okay, so there is a rotation of the body like that. Okay, this is the plane of precision. Basically, this is the plane of precision. Plane of precision. This is the plane of precision, and this is the plane of precision. So that would be the axis of precision. This would be the axis of precision. Okay, when the body is going to be rotated like that in the clockwise direction, when view direction is this, and looking at this direction. Okay, so this would be the axis of precision. What is the plane of precision? Basically, I am going to tell you again. This body is going to be rotated in clockwise direction. Okay, that's fine, but it is also having a rotation like that around OZ axis. That is known as axis of precision. Precision means the direction of omega, change in the direction of omega. Okay, so this is around OZ, that is axis of precision. On the plane is xy plane. This is the plane of precision. Okay, so similarly, torque will be applied by the system on the external agency. See, you are going to apply the external torque to the system in order to provide alpha. Okay, so that couple is known as active gyroscopic couple. But similar torque will be applied by the system on the external agency. Similar torque will be applied. Similar torque will be applied by the system, whatever be your system, it is engine or governor or whatever. Similar torque will be applied by the system. It may be aeroplane, it may be naval ship, whatever. Similar torque will be applied by the system on external agency, on the external agency. And this torque is known as, since it is the torque applied by the system on the external agency, so it is known as reactive gyroscopic couple. Known as reactive gyroscopic couple. This is known as reactive gyroscopic couple. Okay, now you are able to understand what is active gyroscopic couple and what is reactive gyroscopic couple. Okay, and the magnitude would be of reactive gyroscopic couple, that would be same. C is equal to I omega p. So this would be the same directions. Okay, this would be the same directions because this is reactive gyroscopic couple. This would be the same directions, OY directions. Okay, and since this torque which is going to be applied by the system on the external agency, this reactive gyroscopic couple will be experienced by the system itself because that external agency is the part of itself. Are you getting my point? This reactive gyroscopic couple will be experienced by the system itself because the external agency is also the part of system. So that's why this reactive gyroscopic couple, this reactive gyroscopic couple, this reactive gyroscopic couple will be experienced by the system itself because by the system itself because external agency is also the part of the system itself because the external agency is a part of system. Okay, so after the effect of gyroscopic couple there will be an active gyroscopic couple, yes or no? There will, if there is an effect of gyroscopic action, there will be a reactive gyroscopic couple. Let me tell you through the diagram. Let us understand this is the direction of omega. Okay, this is the direction of omega. This is the direction of omega, and the direction of omega is also known as the axis of spin. This is the spin direction. Okay, axis of spin. This is not the precision. This is not the precision. Okay, this is the axis of spin. And this body is going to be rotated in anti-clockwise or clockwise. So, and the what is the plane of precision? Plane of precision is this. After the plane of precision, after the precisions, there will be a new position. This, okay, this would be the new position. But looking at from this direction, this is the view direction. Okay, so that is there will be alpha, that is omega p. We know that. So there will be an active gyroscopic couple. In order to apply alpha, there will be active gyroscopic couple. We know that active gyroscopic couple. Active gyroscopic couple. But we have seen that similar torque will be applied by the system on the external agency. Similar torque will be applied by the system on the external agency, and we know that external agency is a part of the system. So that torque will be experienced by the system also. So that's why the reactive gyroscopic couple would be like that. This would be the reactive gyroscopic couple. Reactive means that the action has opposite reaction. So that's why similarly active gyroscopic couple having the reactive gyroscopic couple. Reactive. This is the reactive gyroscopic couple. Okay. So now you are going to understand. This is basically OY direction. Okay. Here this will be omega and similar speed would be there. Now here, let me write you here. It will be OX. That would be axis of the spin. We know that this is axis of the spin. And what is OY? OY basically axis of gyroscopic couple. This is the axis of gyroscopic couple. Gyroscopic couple. So we have seen the magnitude as well as the direction of the gyroscopic couple, and YZ is basically the plane of spin. Plane of spin. And XY is basically the plane of precision. Plane of precision. And XZ is plane of gyroscopic couple. Plane of gyroscopic couple. So all these terms I have defined here, you can see. And OZ is axis of precision. Axis of precision. Okay. So these all terms I have defined here, you can see in the diagram. Okay. So this is the gyroscopic couple formula, and the direction is decided by this concept. We will solve the questions where you can see how to decide the direction of the gyroscopic couple or the system or the reactive gyroscopic couple. Okay, and we will find out the magnitude also. So this is the basically gyroscopic couple. This is I omega omega p. Okay, this is the important formula. You must remember this. C is denoted as gyroscopic couple. I omega omega p. Okay, so where omega is omega is what, angular velocity. Okay, and this is the precision velocity. Okay, so thank you.